These aircraft have been beautifully restored to display the history of aviation. Maintenance personnel strive to keep them clean to prevent unnecessary mechanical problems. Today's complex aircraft are made of many different types of metals and require additional steps to ensure their longevity. Aircraft corrosion has been a problem since the early days of flight and now costs the Air Force $1 billion annually. As a result, aircraft maintenance personnel must be aware of all aspects of corrosion control. To give you a better understanding, this program will cover identification, documentation, and prevention of corrosion. In order to better identify corrosion, we must understand the theory associated with the corrosion process.
Corrosion is deterioration of a metal because of its chemical reaction with the surrounding environment.
4 conditions must exist for any type of corrosion to occur.
There must be a metal present that has a tendency to corrode. This is referred to as the anode. Secondly, a dissimilar conductive metal known as the cathode must be present. The cathode is less corrosive than the anode. These metals must make contact in order for the electrons to move from the anode to the cathode. A conductive liquid path, known as the electrolyte, is needed to carry the electrical current between the metals. Common electrolytes are water, soil, or salt. The elimination of any one of the 4 conditions will stop the corrosion process.
Now let's discuss the different types of corrosion common to aircraft-related maintenance.
Uniform etch corrosion on a polished surface, such as a shock strut, appears as a general dulling of the surface. If it isn't treated, it can become rough and appear frosted. Pitting corrosion is commonly found on aluminum and magnesium alloys. The first indications of pitting is a gray or white deposit. When the deposit is cleared away, tiny holes or pits are evident. Galvanic corrosion is caused by dissimilar metals coming in contact with each other in the presence of an electrolyte. Hinge areas are commonly susceptible. The pin is made of steel to withstand wear, and the access panel is usually made of a lighter alloy. Intergranular corrosion is an attack on the grain boundaries of a metal. Exfoliation is a visual form of intergranular corrosion that appears as blistering and flaking. Filiform corrosion attacks metals that are covered with organic or carbon-based coatings. It's caused by the diffusion of oxygen and water through the coating. It will appear as a worm-like trail beneath the paint film.
If you find a type that has not been covered in this section, consult TO 1-1-691 or the aircraft-specific -23 or corrosion-related tech data. There are many conditions that influence the outcome of a corrosion-damaged area. Some of these factors are the type of metal, type of electrolyte, availability of oxygen, temperature, time of exposure, stress, and other biological conditions.
Some of the metals most common in aircraft construction are magnesium and aluminum, which tend to corrode easily. Titanium alloys and stainless steel aren't as susceptible to corrosion. Electrolytes form easily on metal surfaces. The rate of corrosion is increased when combined with dirt, engine exhaust, or acidic gases.
Oxygen is also a key factor in the corrosion process. Metal in confined areas corrodes more rapidly than other metal surfaces due to varied oxygen levels.
Temperatures have a serious impact on aircraft and equipment. Hotter temperatures induce rapid corrosion formation and promote mold and bacteria growth. These biological organisms tend to grow in areas of an aircraft or component that remain damp for long periods of time.
Time is an important factor, especially when considering the environment. Some metals will corrode at the same rate regardless of how long it has been exposed. In other metals, the rate may decrease as a corrosion barrier is formed or increase as the barrier is broken down.
Areas of the aircraft that are subject to constant mechanical stress are more vulnerable to corrosion. This includes stress caused by manufacturing as well as daily flight operations. Our aircraft are stationed or deployed to almost every part of the world, exposing them to a variety of different corrosive environments. Coastal regions create one of the most corrosive environments due to high humidity and salt concentrations. Dissolved salt is one of the strongest forms of electrolytes. Industrial pollutants create harsh corrosive environments because of the contaminants released into the atmosphere. Sand, dust, and volcanic ash present other unique problems. These fine particles penetrate sealed components and internal areas and can eventually promote corrosion. Volcanic ash contains chloride and sulfates, which mixed with moisture are extremely corrosive. Ultraviolet and infrared radiation have a severe effect on aircraft. The two combined can cause rapid deterioration of organic and synthetic materials. Currently, the greatest challenge to the aircraft industry is to design equipment that is protected from heat and humidity found in tropical regions. Even though this involves only a small portion of the Earth's surface, it demands our attention.
Familiarize yourself with local conditions as well as the conditions found in deployed locations. With this in mind, it is important that you know the procedures for identification and documentation of corrosion discrepancies.
Corrosion detection is everyone's responsibility. The frequency and extent of aircraft and component inspections will be determined by the parent organization. However, documentation of the discrepancies should be standardized to avoid any misunderstanding and to adequately track any trends that may occur.
If we identify a corrosion problem, how do we find out what the limits are on the damage? Let's start by looking in the applicable tech data.
TO 1-1-691 covers general aircraft corrosion, including theory, preventative maintenance, corrosion treatment, and authorized cleaners and solvents. TOs 1-1-689 and 00-25-234 cover avionics-related corrosion concerns. Additionally, the specific aircraft-23 or corrosion-related technical data is available for each type of aircraft. Next, when annotating the aircraft or equipment forms, you must ensure that a detailed description of the discrepancy is given. This should include the name of the component, its location on the aircraft, and a clear description of the damage, including the degree of corrosion. When entering these discrepancies into CAMs, always use accurate work unit and HAL malfunction codes. Proper tracking may identify recurring problems and aid in permanent correction to these areas. We mentioned earlier about entering the degree of corrosion in the forms. There are 3 degrees of corrosion that are identified in TO 1-1-691. They are light, moderate, and severe. This example of light corrosion shows minor pitting and discoloration. Moderate corrosion may show evidence of flaking and scaling, along with some paint blisters. The pitting can be as deep as 0.010 of an inch. Many of the same characteristics of moderate corrosion exist in severe cases, with the addition of intergranular corrosion and exfoliation. We won't list all of the different aircraft and their corrosion-prone areas, but here are some general problems to be aware of. Fasteners are found in almost every area on aircraft and are often problem areas. These areas are subject to heavy operational loads, moisture intrusion, and possible corrosion from the surrounding aircraft skin. Spot-welded assemblies are highly susceptible to corrosion because of water entrapment caused by holes and gaps created between the parts. Engine exhaust areas are often blistered by heat. Gun and missile exhaust surfaces are also blasted away by high-velocity gases and shell casings causing damage to the protective finish. In addition, these areas can become potential water traps. Wheel wells and landing gear assemblies are extremely susceptible to corrosion because of the elements they are exposed to. These areas are also vulnerable to water entrapment. Open flight stations and aircraft cargo bays are vulnerable to these elements when open to aircrew entry and cargo loading. Engine inlet and aircraft frontal areas, such as leading edge surfaces, are constantly undermined by rain, dirt, dust, and other abrasive elements. Battery compartments offer a unique problem on the aircraft, despite the special paint coatings in these areas. Leakage of electrolytes from the battery cases or fumes from an overheated battery can cause rapid corrosion. Galleys, lavatories, and crew relief areas are extremely corrosive areas because of food spillage and urine spray. The latrine and crew areas should be inspected and cleaned after each flight.
As maintenance personnel, we have the most impact in the corrosion program. Proper maintenance practices and early detection of corrosion areas are key factors in combating the corrosion process. The sooner the problem is identified, the easier and less costly it will be to repair.
Improper use of tools has caused a vast number of corrosion mishaps. Don't use items such as screwdrivers and knives for sealant removal. When you're walking on the top of an aircraft, do you stay within the designated walkways? This has caused structural damage to many areas not designed for the added weight. In addition, it allows moisture to enter these areas. Circuit breaker assemblies need to be cleaned regularly to prevent dust and dirt from building up. Moisture also has a tendency to accumulate in these areas and has been the cause of electrical short circuits and failures. Using graphite marking media such as lead pencils for marking on any metal surface can promote accelerated corrosion. Chalk or grease china markers are the preferred method. A lot of damage is caused by cargo pallets and the tie-down chains used to secure them. Take the time to report these types of damage before they develop into bigger problems. Storage racks help prevent unnecessary damage to panels, doors, and other components that are removed during maintenance. If racks aren't available in your work area, ask your supervisor about getting some. Fuel shop, as well as weapons personnel, should be aware of the corrosion associated with external mounted aircraft accessories. Sway braces and other hardware used for attachment purposes are often the center of corrosive environments. Two of the most important preventative measures are quality aircraft washes and frequent wipe-downs.
The cleaning schedule of an aircraft should be tailored to the environment in which it is operating.
Before starting the aircraft wash, you must ensure all areas that shouldn't be exposed to cleaners and solvents are covered. Check the applicable aircraft tech data for these requirements. Ensure the correct aircraft cleaners are used and the dispenser is set at the proper mixture ratio. Be careful not to direct the aircraft cleaners into areas containing exposed connectors or seal-type bearings. Also, avoid spraying it into areas where there isn't adequate drainage. When you're scrubbing the aircraft, clean the heavily soiled areas thoroughly. Remember, grease and heavy dirt deposits can promote corrosion faster than other areas. Rinsing the aircraft is just as important as scrubbing it. Aircraft cleaners, if not thoroughly removed, will cause a chemical reaction with the metal surfaces. When you have completed the wash and rinse process, remove all the protective devices placed on the aircraft and check areas vulnerable to water entrapment. At the same time, you should ensure all drain holes are free of obstructions. It's very important that you remove as much water as possible from water traps. It may be necessary to open or remove the panels or use forced air to dry these areas. Next, you must reapply the lubricants and greases to the required components. This aids in preventing wear, displacing water, filling airspace, and providing a basic barrier against corrosion. Always refer to the applicable tech data to ensure nothing is missed. Excessive grease around a fitting or lubrication on a hinge assembly should be removed to prevent the buildup of dirt, moisture, and other debris that can promote corrosion. Frequent wipe-downs are just as important as the scheduled washes and can actually cut down on the time you spend in the wash rack. When wiping down the aircraft, pay close attention to those areas prone to corrosion. One word of caution: the use of unauthorized cleaners can promote accelerated corrosion rates on metal surfaces. Use only those products approved for your particular aircraft. Areas that require sealant also require special attention. Thoroughly prepare the surface before applying the new sealant. Correct mixing of the components are essential for proper curing and adhesion. Always check the shelf life listed on the label. There have been many cases where the products have failed or didn't provide the desired effects because the shelf life dates had expired. Additionally, shelf life and extension data can be found in AFM 67-1, Volume 7, Part 3. What do you do with the excess or waste from products once you have completed your maintenance? Each organization should have a point of contact for information regarding proper disposal of hazardous waste materials. Containers for discarding these items should be readily available for your use.
Contact your base environmental management office if you have any further questions about waste disposal. With the information we have covered in this program, you should have a better understanding of the importance of corrosion control. Take the time to document and report these discrepancies as soon as you discover them. And remember, with proper care, it will be the aircraft you maintain that fill the museum exhibits of the future.